Hello everyone. Now in this video we are going to discuss question number 52 of GATE DA 25 exam. Right? This question is for 2 marks and based on the linear algebra subject here. So let's read the question carefully. An n cross n matrix, it means A is a square matrix here of order n with real entries satisfy these particular properties. So this is given to us here, right? And what this a double line indicate, double vertical line? That is basically a Euclidean norm here. So where this denote Euclidean norm, right? And for all the values of x belong to R of n dimension here, right? So which of the following statement is are always correct? Here we have a 4 option. We need to identify which one is correct here. So this is a given to us this particular condition, and this is basically a Euclidean norm here. So you should know what is Euclidean norm first. Okay, based on this only you can solve this particular problem here. Now let's say for example here we have a y vector which belongs to R. It's your n dimensional, which is nothing but this particular thing y1, y2 till yn here, right? Because we have a column vector of n dimension here, values y1, y2 till yn here, right? Now, if I take a Euclidean norm of this particular vector, that is basically like this here, what I'm going to get of y1 square plus y2 square plus till so on yn square. Basically a Euclidean norm here, right? Euclidean distance based on the Euclidean distance, right? So this is basically a Euclidean norm here. And if we take the square of that, so this will be what? Y1 square plus y2 square plus till so on till yn square, right? This is what we got after squaring the Euclidean norm. After squaring the Euclidean norm here, right? Now about this, so we can write this as, can we write this as y1 into y1 plus y2 into y2 plus till so on yn into yn? Can you write this as like this? Yes, obviously. Right? Now, if y is basically a vector, you can see a column vector having this column vector of n dimension here. You can see y1, y2 till yn. Now, can we write this expression as like this? That is basically y transpose into y. Now, y transpose will be like this: y1, y2 till yn, and y will be the column vector here: y1, y2 till yn. And if you do a matrix multiplication, we are going to get the same thing here. It means what? We can write this expression as like this. This is very, very important point to note here. The square of this Euclidean norm is nothing but y transpose into y. This property you have to remember. Very, very, very important. Okay. Now, if you understand this, that's it. You need to apply this property here, and you can then easily eliminate the options here. Okay. Now, let's try to apply this particular property. I hope the concept of Euclidean norm is clear now. Now let's take the given statement here. Here we have Euclidean norm of A into X, right? How we can write this? Can we write this as A into X transpose into AX? Can we write this as like this? Yes, obviously, right? Now, what's the property of transpose here? Let's say, for example, A and B are two matrices here. If we take a transpose of their product, that is basically equivalent to B transpose into A transpose. You have to remember these properties. Okay. So if you observe in GATE DA 25 question paper, your algebraic question was specifically focused on the properties. Okay. So then we use some problem statement, then we use some options, and in order to solve that particular question, you have to apply some properties. So please remember, please go through all the important properties of properties of matrices, determinant, eigenvector, everything you have to remember. All the important properties here. Okay. So can we apply this here? If we apply this here, this will be what? X transpose into A transpose AX here. Right? This is what we can write. Now what about this one? This is basically what? This is basically what here? If I take a square, that will be a X transpose into X. Can we write this as like this? Yes, obviously. Now, this is equivalent to this because it is already given to us. Now this is equivalent to X transpose into X, right? Now by looking at this particular expression, what we can conclude, what we can imply from that? Here I can say that A transpose into A is basically equal to I. Can we imply that A transpose into A basically equals to identity matrix here from this particular equation expression? Yes, obviously. Now what is this? For which case this is basically true? Now this is true for orthogonal matrix. If matrix A is orthogonal, we already discussed this in our introduction to matrices or basic of matrices. If the matrix A is orthogonal, it means what? A transpose into A equals to I. So very, very important properties. If A is an orthogonal matrix, it means what? It will satisfy this particular property. A transpose into A is equals to identity matrix here. So from this we can say option A is correct here. A must be orthogonal. Yes. Option number B. A equals to I, where I denotes the identity matrix is the only solution here. Only solution here. Let's see, because A is orthogonal, so we can use this particular property. Okay, right? Now let's see, for example, if I take this matrix A equals to 0, minus 1, 1, 0, right? This particular matrix. If I take a transpose of this will be what? 0, minus 1, 1, 0, right? And if we take a multiplication of this A transpose into A, give me I here, right? So A can be this one. It's not the only solution. This is also possible. Option B is not correct here. What about option number C? Eigenvalues of A are either plus minus 1. Is it true? For which matrix the eigenvalues will be either plus or minus 1? We have discussed about involuntary matrix. We have discussed about nilpotent matrix. We have discussed about the idempotent matrix. Right? In the case of involuntary matrix, the eigenvalues will be either plus 1 or minus 1 here. Now, we know that A is basically orthogonal matrix here. Now, the one important property of orthogonal matrix is what here? Let's see. Eigenvalues of orthogonal matrix lie on what? Lie on unit circle. It means what? It means what? It is not necessary that it should be either plus or minus 1. Right? No. So option C is also not correct here. And if you see here what I mean by unit circle, you can see mod of lambda is basically equals to 1, right? It can be a plus minus I as well. If we talk about eigenvalues of orthogonal matrices lie on unit circle, it can be plus minus I as well. It can be complex number as well here. Okay? So remember this important point. So option C is not correct. This will be only correct if we say that A is a symmetric matrix. If A is symmetric matrix, it means what? A square equals to I. Now what is this A square equals to I? We already discussed. It is basically involuntary matrix. Right? And the property of involuntary matrix is basically what? Eigenvalues of this involuntary matrix either plus 1 or minus 1. So this will be true only when if A is symmetric matrix. Okay? It is not mentioned in the question whether A is symmetric or not. If we say that an n cross n matrix is basically a symmetric matrix, in that case option C will be correct. Okay? But not always correct here because A is not a symmetric matrix here. Okay? I hope you understand why option C is not correct here. So as of now, only option A is correct, not B, not C. What about D? A has full rank. Now we know that A transpose A is equals to I, right? So if I take a determinant on both sides, determinant of A transpose A equals to determinant of I, which is basically equals to 1 here, right? But what is this determinant of A transpose A is basically what? Determinant of A whole square. By the property of determinant here we can write which equals to 1 here. It means what? Determinant of A will be either equals to plus minus 1. It means what? A has a full rank, it is basically a invertible matrix, right? It is basically invertible matrix. It's a non-singular matrix, right? So option D is also correct here. I hope you understand the video solution of this particular question, right? This is very important what we have discussed, Euclidean distance. If you understand these particular properties, then you can solve this question. Also, you should remember all the properties of matrices and determinant here. Okay. So this question is simply based on the application of the properties. That's it. Okay. So I hope you understand the video solution of this particular question. Thank you.